Hey everyone, welcome back to another video about related rates problems. Today we're going to talk about a type of problem called the police cruiser. And anytime you're dealing with related rates, we want to remember that there's different types of problems and there's some really common themes to these problems. For example, some of them involve similar triangles and setting up a proportion. Some of them involve a right triangle and using the Pythagorean theorem. Other problems involve using volume or area functions. And so today we're going to talk about what's happening with police cruisers driving along at an intersection. So let's read through and remember that our steps for resolving a related rates problem are always the same. Number 1, draw a picture. Number 2, write down what you know. Number 3, write down what you want to know and when you want to know it. Number 4, write an equation relating all those variables. Number 5, differentiate that equation with respect to time. And then number 6, go back and plug in the information that you wrote down in steps 2 and 3. So let's get started. Let's draw a picture. So we have this intersection, and it's a right-angled intersection, okay? And we have this police cruiser approaching from the north. So here I'm going to have car number 1. I'm a terrible artist, but we'll draw a little car. I'm going to draw a little arrow showing that he's going this way. So this is the police cruiser, and he is chasing a speeding car that has turned the corner and is now moving straight east. So now we have this other car, so here's east. And so we have this speeding vehicle, and he's moving this direction. He's moving straight east. So we have our picture here. We've got a right triangle, so right now, or right angle, so right now in my mind I'm thinking to myself, this might be a Pythagorean theorem type problem. Let's see. And now let's write down what we know. We know when the cruiser is 0.6 miles north. So we need to get some variables floating around in here. I prefer using x and y. So I'm going to call this distance here, we're going to call it y, and we're going to call this distance here x. It's just nice and easy. Sometimes when you use other letters like S or C or other letters of the alphabet, they can sometimes look like numbers, and it can be confusing. So I'm going to use x and y. So when the cruiser is 0.6 miles north, so when this y distance, when y is 0.6 miles, x, the car, is 0.8 miles, the police determine with radar that the distance between them and the car is increasing at 20 miles per hour. Now, this problem is a little tricky because when it says the distance between them, they're talking about the linear distance. So this distance right here, we're going to call this d for distance. When x and y are these values, and actually maybe d is not a great option because dt is a, that's a lot of the letter d floating around. So let's call this z actually. So we'll call it dz dt is increasing at 20 miles per hour. So it's going to be a positive value if it's increasing. If it ever says it's decreasing, we note that with a negative sign. So if the cruiser is moving at 60 miles per hour, so here's what we want. If the cruiser, so dy dt, is moving at 60 miles per hour, what is the speed of the car? Now let's think about this. 60 miles per hour is his speed, but his velocity needs to be directional. He is moving southward, he's moving downward. That distance y is decreasing. So we're going to put a negative sign because of the direction that the police cruiser is going. So we want to know at this time, so at when do we want to know it? When all this is happening. We want to know dx dt. So really this dy dt needs to be up here. So the cruiser is moving at negative 60 miles per hour. What we want is dx dt when these 4 values are happening. So let's rewrite this then. We want dx dt. All right, let's set things up. Looks like a Pythagorean theorem. I think that's the approach that we're going to take. So my equation is x squared plus y squared equals z squared. So when I go to differentiate this with respect to time, I'm going to have an x, a y, and a z in there. I'm also going to have a dx dt, a dy dt, and a dz dt. So if I have two measurements, I need to find z at that instant also. So I'm going to use these to find z. So I'm going to go over here, x squared plus y squared equals z squared. So I'm going to say 0.8 squared plus 0.6 squared equals z squared. 0.64 plus 0.36 equals z squared. Oh, z must be 1. So that's handy. So z is 1. So now I have all the pieces I need. I'm going to go ahead and differentiate with respect to time. So I'm going to have 2x dx dt plus 2y dy dt equals 2z dz dt. So now I'm going to plug in everything that I know. I'm given an x and a y, and I found z. So 2 times 0.8, and then dx dt is what I want. So that should be the only thing left when I plug everything in. So 2 times 0.6, dy dt is negative 60, equals 2z, that's 1, and then dz dt is 20. So that's increasing, so it's a positive value. Hey, I plugged everything in. Dx dt is the only remaining unknown. Now I'm ready to solve for dx dt and get my answer. And after I do a little bit of arithmetic, I get that dx dt is 70 miles per hour. So let's make sure that this makes sense. When I look at what's happening, my police officer is chasing this speeder who's moving away. The distance between them is growing, so it makes sense that the person who is speeding should be going faster than the police. And so he's going 70 miles per hour. His distance from the origin is increasing, so we have a positive rate of change. All this to check and make sure that our answer does in fact make sense. So he's outrunning the police at a mere 70 miles per hour. I feel like the police need to step up their game. Hopefully this has been a helpful video for you to help you understand better these Pythagorean theorem type problems. Remember, you're always going to have the information that you need within the problem. It just might take you a little bit to pull that out and to solve and to find the missing pieces. So don't ever be afraid to go back to the beginning and start over. You guys, you can do this. The more you do, the better you're going to get at these problems. Keep at it. You've got this.